All right. Hello, everyone. My name is Vipul Raheja, and I'm an applied research scientist at Grammarly. And today I'm going to talk about building intelligent and interactive writing assistants in the era of large language models, done together with my excellent coworkers and collaborators over the past year. So, to kick things off, let's talk about the writing process to lay down a framework for what people do when they write. There has been extensive research done on the theory of writing, dating as far back as the 80s. It describes writing as a complex and effortful cognitive task where writers balance and orchestrate three distinct cognitive processes: planning, translation, and revision. However, contrary to this theory, in practice, the writing process jumps ahead or leaps behind. It's not linear, it's actually recursive. And as we write, we may jump ahead to a later stage of the writing process, or we might revisit a prior stage. And this work focuses on text revision as an essential part of the writing process. It enables writers to deliberate over and organize their thoughts, find a better line of argument, learn new things, and discover not what was not known before. So while text revision is a strategic and an adaptive process, it's more importantly an iterative process, because human writers are unable to simultaneously comprehend multiple demands and constraints of the task when producing well-written text. For instance, expressing the right ideas, covering all the content they want to cover, following the linguistic norms and discourse conventions, and so on. And therefore, human writers, we turn towards making successive iterations of revisions to reduce these number of considerations that we have to pay attention to at each time. And this phenomena of iterative text revision is the topic of my research that I'll discuss with you all today. So, similar to the way the differences that we see in the writing process with large language models, the processes and paradigms of writing assistants have also undergone a major shift. And broadly speaking, conventionally, writing assistance has been a system-driven or a push-based protocol where a user would type their text, the system would evaluate it against some machine learning models, provide a set of suggestions, which the user could then accept or reject. And this would go on for a few turns until the system didn't detect anything worth improving. But more recently, in addition to the prior paradigm of a system-driven, click-heavy interaction, we see we see more user-driven systems. It's now more of a conversation with a large language model powering the system, providing a much more collaborative revision experience, as opposed to the system providing prescriptive suggestions that the user had no control over. So here you can see that this interaction with the writing assistant starts even before a single word in the final document is written. So the user can write the first draft like they did before, or they can now provide instructions or input about what needs to be written, or and the system can then generate the first draft. And then the evaluation proceeds pretty much in the same way. But now at the revision stage, the user can either continue revising themselves as they did before, or they could rely on the system to evaluate the revised document and suggest further improvements. Now, if the user chooses the latter, the system could then go ahead and make the revisions. And this interaction then evolves like any other conversational agent, where it's a back and forth between the user and the system about what edits the user wants and what they want to change before they finalize anything. And in addition to being conversational, the scope of editing done by the system is also now much, much broader. So if we remove the older way of composing and revising things, we are left with this. And if unraveled through time, it looks something like this, where, as you can see, looks like a user having multiple interactions with their writing assistant. And this sequence of interactions spans multiple stages of the writing process, right from ideation to composition and multiple rounds of evaluation and revision. So therefore, the new paradigm of writing assistance brings with it a lot of challenges. In reality, while we are quite far from addressing these challenges, as we are still in the phase of understanding the writing process and the changing writing assistance process, we have still made some progress in the direction of understanding what the writing process is, how can we model the writing assistance to provide better quality suggestions to users, and finally, something along the lines of human in the loop collaborative revision from the perspective of users being able to leverage intelligent writing assistants much better than they could before. So diving a little deep into how we understood these three dimensions of problems in the space of iterative text revision, we first created a generalizable edit intention taxonomy of text revision, which can be applied across different domains to help understand general human editing behaviors. Using this taxonomy, we collected complex text editing annotations with crowdsourcing across these different dimensions. And using this data set that we collected using this taxonomy that we proposed, we computationally model the process of iterative text revision using state-of-the-art text editing and text generation techniques, and provide insights into the modeling challenges of the task. And finally, we built a human-in-the-loop text editing system to make the revision process more interpretable and efficient. And by analyzing the edits made by our text editing models and comparing them against human editing patterns and text quality metrics, we take a significant leap in understanding and exposing the challenges to computationally model the task of iterative text editing, and therefore the name iterator. So as part of our first focus on the first research question, we started exploring the writing process itself. And in the interest of time, I'll keep this section short and refer you to our paper from ACL 2022, where we proposed this taxonomy for text revision based on edit intentions. And then we collected a large-scale data set of iterative revisions in the wild based on this proposed taxonomy. So more specifically, for our taxonomy of text editing, we focused on non-meaning changing edits. And as you can see some over here, there are 4 different edit intentions that we further identified. Edits that improve the fluency, clarity, coherence, and style of text. And you can already see that this taxonomy is generally applicable to multiple domains, multiple granularities, and multiple revision depths. So how did we exactly do this? In a nutshell, we first collected a large data set of raw documents across different domains, such as Wikipedia, archive, news articles, because they have different writing goals, different writing patterns, different editing intentions. And each document, most importantly, comes with its revision or version history. You have Wikipedia articles, scientific papers, or archive, which are iteratively edited and persisted as new versions. So for each document, we sort each version according to its timestamp in ascending order, and we pair 2 consecutive versions as one revision. So over here, you can see version 1 and version 2 are paired as revision at depth 1, version 2 and version 3 are paired as depth 2. And for each sampled document revision, we extract its full set of edit actions. And then we use Amazon Mechanical Turk to crowdsource the edit intention annotations according to our proposed taxonomy. And then again, in the interest of time and the focus of this talk, I'll refer you to the paper for details of how exactly we collected this large-scale data set. But to summarize, this data set gave us this taxonomy, and the data set collected on the basis of this gave us a foundation to understand the process of iterative text revision and build a system on top of it. So in this next section, I'll cover the various modeling approaches that we explored to figure out and understand the writing process using the taxonomy and the data set. And this will simultaneously address the next 2 research questions as to how can we better provide higher quality relevant suggestions for various writing tasks. and how can we make the writing process more efficient and effective for writers. So when it comes to modeling the writing process, over time, we have seen three distinct patterns which forms the body of our work. These are called system-driven, user-driven, and mixed initiative writing assistance systems. They mainly differ along three axes. The first one is interaction, defined as who out of the human or the machine drives the revision interactions. The second one is revision, defined as who out of revision and machine performs the revision. And the third one is evaluation, defined as who out of human and machine evaluates the quality of the revised text and drives the next steps in the interaction. So our first work, called Deliterator, is quite system heavy. Then we followed it up with another system called Coedit, which is mostly user-driven, where we leverage instruction tuning with large language models to enable the user to drive the initiative and the evaluation. And finally, we propose a more balanced and collaborative system called CTRLHF, where we leverage both human preferences to empower the user and the system to collaboratively drive the revision process. And that enables a much more balanced and higher quality revision experience. And one thing to note here is that the machine, by design, will always be a primary driver of revision, because we are talking about writing assistants. So diving a little bit deeper into these three different systems, I'll first describe the system-driven model, which is called delineate and edit iteratively, or deliterator. So here's a bit more detail on how we modeled the system-driven writing assistants. We propose a two-step approach to text editing, where we first perform the edit intent classification, where we first predict the spans that need revision, and then the type of revision needed by edit intention, and which could be one of fluency, clarity, coherence, and style, going back to the taxonomy that we proposed earlier. And then for the predicted sentences or spans that need revision, a text revision model, which is essentially a generative model, will make the actual edits, and that leads to a new document revision, which leads to a new version of the same document. So here we see that given a document with, let's say, n sentences, we take a context window of k sentences. So this is shown with k of 2, so a window of every 2 sentences. We'll first predict the spans using the edit intention classifier. We'll predict the spans that need revision. And also we will label the edit intention, the kind of revision that's needed. And then for the predicted sentences or spans that need revision, the text revision generator will make the revision, leading to a new version of the document. And this process will then repeat till the system predicts that there are no more revisions that need to be made, leading to the final edited document. So this was deliterator. Now I'll describe the user-driven model called Coedit. So in contrast of deliterator you saw was mostly system-driven. The system was figuring out what to do, and the user was just proceeding with that. In Coedit, it's called collaborative text editing via instruction tuning. We explored in this work the other end of the spectrum, which is we gave the full control to the user to drive the revision process. And as you can see, over many iterations, the revision interaction, the revision itself, and the evaluation is all driven by the user, where the system is sharing just the main responsibility of the revisions. So the user will tell the system what to write, what edits to make, and so on. So that's the evaluation part. And of course, based on that, the interaction is also being driven. So in Coedit, we essentially replace the automated system-driven edit detection and revision of deliterator with a more user-centric interaction, where the user can now provide instructions in natural language, and the revision model, which is an instruction-tuned large language model, it can perform the edits. Note that the user can also make revisions here. So In this revision interaction, the revision itself and the evaluation, it's all driven by the user, and the system is sharing just the main responsibility of the revisions. And one can argue that this is the other extreme, from being mostly system driven to now mostly being user driven here, as I said before. And because of this nature of this, there's you can also see that there's a conversational aspect to it here. The user says something, the model responds with something, and the user then says something different, and it proceeds like a conversation towards a goal, the goal of arriving at a high quality document which the user is happy with. And because of that formulation, it comes with it with its own challenges of modeling different conversations. Finally, we come up with CTRLHF, which tries to address the limitations of both the previous systems pertaining to interaction, revision, and evaluation, and where all the three aspects are a collaboration between human and the machine. For example, here, the user will ask the system to write something, the system will generate some output, the user can then either make changes themselves or they can ask the system to make some changes. In this case, evaluation and interaction are both going hand in hand. Similarly, revision is also very collaborative. And as you can see, every stage has both human and machine responsible for driving it. So if we look at a more simplified version of CTRLHF in the context of the older architecture diagram that I've been sharing, in CTRLHF, given a document in the revision cycle, which could have been created by a human or in collaboration with a text editing system, we replace the predominantly user-driven interaction with a more collaborative way to do things. And now the evaluation can also be done by both human and machine. They can collaboratively decide the next steps in the revision process. And we do this in two ways. We leverage human preference learning, or RLHF, reinforcement learning from human feedback, where we look at human preference data for text editing, which was essentially iterator that I talked about before. And we train an instruction-tuned text revision model that can make revisions that are better aligned with human preferences, basically what we did in co-edit. But also, we use large language models for evaluating the quality of text. We use them as text quality evaluators. So we leverage an ensemble of 4 different large language models to first understand the quality of a given piece of text, along with different evaluation criteria. And the output of this ensemble is used to provide the reward to train the text revision model, as well as to predict what kind of edits need to be made at the next step of the revision process. So both of these works are under review, but hopefully they give you an idea of how we arrived at this formulation and how we're able to introduce collaboration in all aspects of the system. And in the next section, I'll present some results pertaining to the modeling of and human-machine collaboration. So across our modeling and human-machine collaborative writing explorations, we have observed that while instruction tuning has been an incredibly powerful technique to improve the quality of revisions, RLHF training is able to improve it further, especially along the more subjective criteria such as style and coherence. In contrast, we also conducted experiments with ChatGPT, and while it's able to outperform our systems on style and fluency tasks, it lacks much far behind on coherence and clarity tasks. And that can be attributed to the verbosity or the more creative liberties ChatGPT will take to make edits. And that could be good for paraphrasing, but not so good when it comes to correctness, for instance. And at the same time, our models are able to do this while being much smaller, almost 2 orders of magnitude smaller than ChatGPT. And again, I'll refer you to the papers for all these results. Secondly, we also conducted human evaluations, qualitative human evaluations, by asking qualified users to use our system for iterative text revision using different models at the back end. And what we found was that in terms of human evaluations, the ratings were in line with the automated metrics, where automated metrics that I just shared in the previous slide, where CTRLHF did better than Coedit, which did better than Deliterator. However, ChatGPT scored quite close to CTRLHF, which was in turn better than automatic evaluations. And this indicates the limitations of automatic metrics and that there's a huge need for better document level evaluations for text editing. And finally, we also measured the efficiency of this mixed initiative by removing the human interaction from our system. And we asked 3 qualified annotators to evaluate the revisions made by our system for a set of documents, which had at least 3 revisions per document. And this gives us the system-only baseline, and where annotators were asked to judge only whether the final revised documents have improved quality. And we can see in the results where the human-machine interaction helps produce higher quality of revised documents with a fewer number of edits and fewer iterations of revisions on average. And this validates the effectiveness of human feedback in the revision process, which can help filter out noisy edits and further improve the quality of the final revised documents. Another interesting insight is that mixed initiative setting had led to a slower revision process, which means that while the amount of work was reduced, it still made people slower as they had to evaluate the system suggestions more. And this is something that we plan to address in future work. Speaking of future work, to sum up, our proposed systems demonstrate improvements in quality, effectiveness, and efficiency of writing assistance. Our computational modeling of this process of iterative revision has progressively gotten better thanks to the advances in text generation, thanks to large language models, which is evidenced by both qualitative and quantitative evaluations. We found that human-machine collaboration works much better for revision than any other alternatives that skew the control of interaction, revision, and evaluation to either the user or to the system. And finally, while collaborative revision improves the quality of writing, it also leads to slightly slower revisions. That's something that we plan to address further. So finally, in terms of future work, we aim to improve the contextualization of our systems. We want to make them provide better suggestions for different users and different writing needs. We hope to invest some effort in formulating better evaluation frameworks to address the gaps in evaluating the task of revision, accounting for document level quality, revision history, and user preferences. And finally, we aim to improve this human-in-the-loop writing process by learning to provide the most effective suggestions. So finally, I'd like to leave you with some examples of how we are leveraging this research in the Grammarly product. The first one is Grammarly Go, which is Grammarly's large language model powered offering. And this has been generally available for a few months now, where you can just tell the system what to do. It'll generate some first drafts for you. You can compose some things based on any prompts that you give to the system. You can rewrite existing text based on any feedback that you provide to the system. And finally, you can make quick replies for any communication needs. And another one is a version of the same thing on mobile, where we leverage speech as users' input to articulate what they want to write about. And we give them the ability to compose and edit documents, messages, notes, and so on. All of that with their voice, which makes the writing experience convenient and easy to use on the go. And that's it. Thank you so much, everyone.